as I'm John Long, I'm with LCR Embedded Systems. For you guys who don't know what we do is we do basically electronic packaging, chassis, backplanes, and some systems. If you look at really the customers we target, it's ones who are ready for field deployment. So almost all of our products, while 90% of them are based on standards, either VITA standards or PICMIC standards, they're highly customized to meet the customer's deployment environment. You know, one of the big challenges here with this group is what the heck do we talk about, right? Is you have cloud computing, you have aviation safety. We bend sheet metal, and it's not necessarily the most exciting topic. So, you know, we got together at the beginning of this year and said, what's interesting we could talk about? You know, engineers came up is, how about shipborne shake and vibration? That topic is really dull, let me tell you that. It's our living, but it's not the most exciting topic. Someone came up with the VITA Shelf Manager standard. And, you know, at least in the ATCA world, the shelf manager somehow got stuck with the chassis. And we've seen, at least on the ATCA side, that on big complex systems that are field deployed, is there a new strategy for maintenance on them, right? Is the warfighter, that 18, 19-year-old kid, can't really troubleshoot these complex systems, so they're coming up with ways to remote into the system and fix issues that are really technically complex. Nice, but again, kind of dull. And then we said, well, what are we seeing in trends and applications? Because we're dealing with customers when they're starting to do, you know, low-rate initial production runs and shake the bugs out of the hardware is, if we see 2 to 3 of the same applications a year, we think, hey, that could be a trend. There's been some radar applications this year. In probably 5 or 6 years, as you'll see several of the DoD departments rolling out major new applications for radar. And the other one is communications, specifically LTE. There's been a lot of talk in LTE. And I would say in the last 18 months, we've probably talked with 4 different customers who are looking to more ruggedized package LTE equipment, which means it's getting more and more real, and you'll probably see it being deployed by someone in the next 3 to 5 years. So we'll talk about what we kind of see as, you know, potential markets, the advantages of LTE, even though a lot of folks are aware of those, the use cases, and then some of the challenges. You know, potential rugged LTE users. You have the DoD. You know, US was going down the path of JTRS, which is a joint tactical radio. They killed it 2 years ago. They're still kind of struggling with what they want to do. There's foreign militaries. Some of them are moving quicker on it. First responders is probably the first folks out. FCC mandated a couple years ago that all first responders must migrate to LTE. Of course, they didn't provide any funding for it, but they all have to move there. ITU has also recommended globally that all first responders move to LTE. Some of the other applications we see is a lot of the companies that are extracting natural resources, right? Mining, oil, they are located in areas that there is absolutely no infrastructure. If you look on offshore oil wells, some of the mining, they have nothing. And so they're a potential target for LTE. And the last one, and I think the most atrocious one from my perspective, there are some customers that want to put a cell tower, for lack of a better term, on commercial aviation planes so you can continue to use your cell phone and talk over it normally throughout the flight. And I hope that one fails, but it will probably be successful. Advantages to LTE, right? You know, the user interface is always important. And when you look at the DoD, they're probably the worst case. I think Jerry said, you know, what's the average age of the, you know, 18, 29-year-old soldier? Well, actually, we looked it up because I was intrigued by what it was, and this was from 2013. So Marines have the lowest. The average age of a Marine is 25 years old. The rest of them is about 29 years old. So, you know, they're younger than me. They may be about half the age of Jerry. I'm not quite sure about that. But, you know, if you look at the radios the Army's deploying, there's 2 of them. They're the latest jitterators. One is a single channel man pack. The other is something can be man packed or vehicle packed. They're not very intuitive, right? You look at them and go, huh. You look at them and you compare them to the latest cell phones out there, they're intuitive. I look at the 25, 26-year-old engineers we have. If I can't get something to work with my cell phone, I just give it to them, and it takes them about 30 seconds to figure out and go, this is what you need to do. So, from a user interface, what the smartphone technology rolled out with LTE is very intuitive, and all the war fighters are very familiar with it. When I was looking for that picture of the Rifleman radio, I came across some of the marketing literature for the platoon level soldier that this company did. And one of the benefits is you can take your smartphone, hook it up to the radio, and text with your platoon and send pictures to them. My initial thought is, okay, these guys get it. It's not an intuitive interface. But then I thought, that's really, really almost scary that I'm out on a mission. Maybe I can't talk because of where I am. So I pull out my cell phone, I attach it to my radio, and I start texting the guys. It just seems stupid. So obviously on user interface, LTE in the modern technology has an advantage. And this is a slide we borrowed, and this looked at bandwidth of LTE versus mobile radio. And you can see that the commercial technology is far outstripping the radio. I think there's two reasons for it. One is just a pure dollar value of investing in the LTE. I could not find a number on it, but I bet you it's probably 10 to 20 billion that everyone has spent worldwide to make LTE real. And, the military on the jitters, they spent about $6 billion for the development and initial units. The second one also is some of the design considerations they made. If you really look at the background of LTE, they wanted to design it for how much bandwidth can I get out of this to the user. And they made design considerations and changing the frequency and the technology to maximize that. If you look at the military radios, they went with SDR, software-defined radio. It's a great technology. It can be really secure. The problem is you can change the waveform, you can change the frequency, and because of that, you don't have a lot of predictability. So, those are the two reasons you see it, the commercial dollars and just technology decisions. And the other one is, the cost. And when the Army, at least, decided they were going to kill jitters, there was a lot of relooks at it. And it took them 15 years ago, so they started it in the late 1990s. They spent $6 billion on it. I think they realized it was really complex. So, if they want to start, if a DoD wants to start from the ground up a new technology and not adopt a commercial, you're probably looking at a minimum of $6 billion as an entry-level cost. If you look at LTE, it's widely adopted. There's folks who understand the design of it. There's folks who understand the architecture of it, and it's something simple to do. And, one of the other ones is a handset, because if you look and when they deploy it, the handsets are probably the most expensive item. The big radio stations or sets, you don't need a lot of them. The handsets, you need a lot of them. And that radio that I showed earlier, the list price of that was about $2,800. You can buy the new Galaxy 4 with no term contract from Samsung for about $750, and they'll throw 12 months of Netflix in it for free. But you can see you could take that base technology, you could customize it to a large extent, and you still have $2,000 to play to get to the same cost level. So let's talk about the technology, because when we talk about use cases, having a very, very basic understanding of the technology is going to help out. And I think most of you guys know this, is you have the user equipment, whatever that may be. And there can be a million different types of user equipment. You have what everyone refers to probably as a cell tower, and in LTE it's eNode B. What the eNode B basically manages a radio interface and optimizing that. And it also does, if you go down to the OSI, layer 1, some layer 2, some layer 3. So it's really basic stuff. Then you have the EPC, or what I would kind of view as a basic network. It does the billing, it does the call control, it manages the switching of the traffic, and all the things we would think of a traditional network. Now, when you look at the different deployment cases, 99% of them have the same technology. It's just how do I separate the eNode B and the network itself. So let's go to what the ones that are starting to be deployed today. And these are for large fixed locations. And you could think of them as base protection. You have a large military base in Afghanistan, you want LTE coverage in it. Or you can think of natural disasters where it's a mass natural disaster. And you also have, sometimes you'll see these at football games or other sporting events. You know, where I grew up in Iowa and a cow was an animal, what they call this as a cow is a cell system on wheels. You know, it can support hundreds to thousands of users. It has the eNodeB and the EPC all combined on that one platform. It usually has a power generator, it has the antenna, it may have satellite or radio backhaul, and it can support remote EPCs. That if you want to put an EPC or eNodeB another mile or two away, you can deal with that. And so these are out there. They're starting to be deployed. One of the interesting ones is how many folks saw right before the Christmas time where Raytheon put 2 J lenses near the White House? All right, no one. What J lens is someone came up with a great idea is for radar applications. Instead of having a plane or something to get to altitude or building a big tower, why don't you, what I would call a blimp, put them on a blimp. The technical term is aerostat, and the aerostat is connected to a tower and all the power and communications go up that. Is a lot of folks are now looking at to do that on an aerostat. And if you think of a really bad natural disaster, let's say the big earthquake finally hits California, is the infrastructure is basically destroyed. There's no easy way to get the trucks and other equipment in there. You could put one of these aerostats over there and quickly provide some services. So it's not always going to be ground-based, but it could be up on a blimp or an aerostat tethered to a tower. And again, you'll see this, and you'll see a lot of commercial deployments. But all the first responders are looking doing things like this, and the military is looking at doing items like this. The second one, and I wasn't sure what to call it, but I would say highly mobile is probably the best one. And this is where you put it on an airborne platform. Some of these have actually been deployed, I believe. Doesn't support a lot of users, supports tens of users. You know, the picture you have there is one actually on a helicopter from a couple of years ago when NavAir was doing some basic testing to say, does this actually work? So, you know, other ones we've seen is people trying it in a UAV. We're working with a customer that wants to put it on a wing of an aircraft. They haven't told us that much, but it needs to be lightweight and small. In a lot of these cases, because of the swap constraints, is you're only going to put the eNodeB portion. And you'll either satellite backlink to that EPC that could be a long ways away or, you know, some other place. You could put both of them, but you would start adding weight. And again, these are for highly mobile locations, and, you know, the type of folks that will deploy this as a special operations command, right, is you need broadband communications where an operation is going on. It may be in a place where really not supposed to be, so you can get it there quickly and get it out quickly. You know, the last one is ground mobile, and it's more of a tactical one. And, you know, the easiest one would be a platoon out in the desert somewhere, is there's no other networks around them. It's not really easy to backhaul. You could do it by satellite, and can I get something mobile? And the other example to me is one that a lot of folks understand is, do you guys remember smoke jumpers when you were young? The guys that jump out of airplanes to put out forest fires? Is they go into situations where literally if you have to jump out of a plane to get there, there's not even roads to get there. So, you know, something like this would be perfect for them. They could bring a communications network that's probably a bit better what they have today out into the middle of nowhere and run it. Again, it supports tens of users. It can contain the eNodeB and EPC. You probably can connect to, you know, the network by satellite links or other ones. There's ways to get out of that. But one of the interesting technologies, and a couple of customers are playing with this, and there's some research going on, it's called swarming. And it's kind of creating or ad hoc networking for this. And the concept is within the EPC. The EPC, you know, is getting all these signals from the eNodeB, and the EPC is looking for other cell sites out there or other of these tactical nodes. And so what it'll do when it sees another tactical node, it'll join to that tactical node and it'll link them together. So if you have these, let's say the useful range was 1 kilometer, if another one of these cell sites comes in within 1 kilometer of it, they will link together. And now again, as I can't remember who was talking, is how do you start linking these networks together? And it was on the Bluetooth, is you can start building more and more ad hoc nodes. I'm not sure if that's going to work out, but it's a really interesting thing if it can, because you can start building these ad hoc networks, and I think that would really help first responders and the DoD applications. So far it looks nice and easy, right? Everyone should deploy it. Well, we'll get to the ugly ones. The biggest challenge is radio bands. Is, the ITU and the 3GPP, when they developed LTE, optimized it for radio bands. And these are specific frequencies. Worldwide, they assigned about 44 bands for LTE. Band 14 for the US is for the first responder, or the FirstNet for the first responder, so they have a dedicated band they can use. But there is no open band anywhere in the US that you can use. And I mean by open that you can put commercial equipment under there. Or you can put your own equipment under there and you don't have to buy spectrum from someone. Cisco and some of the tech folks are petitioning the FCC to open up a band for free use or open use by anyone. I believe the FCC said they'll look at that at 2017, 2018, so you probably can forget about it. The other option would be buying it, and just to give you an idea, is T-Mobile bought one band that covered half the US population. The beginning of last year, they only had to pay Verizon $3 billion for it. So, the biggest challenge in all this for non-DoD or non-first responders is you can't find the frequencies out there. When you go back to the DoD, the other one is security. The DoD is very comfortable with the concept of software-defined radios. It allows the same radio set to basically have different levels of security. You want to talk to the higher echelons, you go to a different security level. You're talking to the platoons, you have a different security. It changes waveforms. You also can download new waveforms on it. So for an enemy to identify what waveform you're using at any one time is really difficult, and you can put a lot of different securities in there. So they're very comfortable with it. Potential solutions for LTE, and we know there's work going on putting in encryption on the cell phone and also on the eNodeB, and that would encrypt the link between them. It would have to be an encryption algorithm that if it got in the wrong hands, you wouldn't be too concerned about it because someone's going to lose their cell phone. The other concept is they're arguing in the DoD is hiding in plain sight. Let's assume you go to some country, and I'll assume probably the least populated country in the world, or if you go to an African country, there's probably 40% penetration of cell phones. So you're going to have millions of cell phone signals out there. If you go with an LTE solution, maybe you're just hiding those signals with the millions of other signals out there, and they'll never be able to discover them anyways. So, it's an interesting concept, and I think it's going to take a while for that to pan out. So where do we think it's going? The US, I think DoD is doing trials right now. I think you'll see them speed up trials. I believe some customers will put an SDR interface onto LTE to make them all happy. Foreign military, some of them are moving quicker. I think within the next couple of years, you'll see some contracts awarded for fairly large deployments overseas. First responders, they're all looking at it. They all want to go there. The way it was set up is a quasi-government organization called FirstNet controls all this. They have no funding. They're relying on the local municipality to do funding, and it's expensive. So it'll take a while. And the example on the expense is LA County did an RFQ about 18 months ago for their FirstNet, and I believe when they tallied it all up, it was in the billions of dollars that they would have to spend to roll out a first responder LTE network. Remote locations, if you ever can solve the bandwidth issue, that would be good. And the commercial aviation, I hate it, but I'm afraid it's going to be successful at some day.